Bismillahirrahmanirrahim. Network Programming ITT 4.0, final chapter, parallel programming in Python. Alright. So content outline 9.1 thread versus process, 9.2 parallel versus concurrent, 9.3 the Python parallel programming ecosystem. So by the end of the lesson, students should be able to understand the basic concept of CPU hyperthreading, and students should be able to write parallel programming in Python. Okay, so the first one kita tengok thread versus process. Alright, so kalau kita pasang dekat logo Intel Pentium 4, kamu pernah tengok tak? Mungkin kamu dah belajar-belajar terus ada Intel Core 2 core ke, Core 2 Duo, i5, i3. Tapi sebelum tu kita ada Intel Pentium 4. Kan, dia ni dah ada hyperthreading, dia ada simbol HT kat sini. Okay. So hyperthreading was Intel's first attempt to bring parallel computation to consumers' PCs. It debuted on desktop CPU with the Pentium 4 HT back in 2002. Kan, berapa tahun lah? 22 tahun. Kan, 22 tahun lah. Okay, Pentium 4 HT. A single physical CPU core with hyperthreading appears as two logical CPUs to an operating system. So while the operating system sees two CPU for each core, the actual CPU hardware only has single set of execution resources for each core. Kan, dia OS akan nampak macam ada dua CPU, ada dua core. Kan? Macam dekat saya punya laptop pun, kat mana task manager, kat mana CPU. Okay, so CPU i5 berapa core? 4 saja, 4 core. Okay, tapi dah ada HT, so dia akan nampak double lah. So view show chain graph to logical processor, so dia akan nampak macam 8. Padahal dia ada 4 saja. Kan, dia ada 4, tapi kerana ada HT hyperthreading, so dia nampak seolah-olah macam ada 8 core. Kan, kalau yang 8 core ada HT nampak 16 lah. Betul?
Betul.
Untuk i5 4 core ada 4 saja sini. Kan? So dia akan nampak HT, dia akan nampak jadi 8 lah. Seolah-olah ada 8 prosesor, 8 CPU, 8 CPU lah kan. Tapi dia sebenarnya 4 saja. Alright, so hyperthreading allows the two logical CPU core to share physical execution resources. Hyperthreading can help speed your system up, but it's nowhere near as good as having actual additional core. Hyperthreading ni boleh bagi laju, tapi kalau ada tambah core yang real physicalnya, itu lagi bagus lah. Kan? Okay, untuk multiple core, originally CPU had a single core. Okay, that means the physical CPU had a single central processing unit on it. Okay, kalau zaman dulu memang dia single core saja. Kalau kata server ke mainframe ke nak pakai motherboard tu, dia boleh letak banyak CPU, boleh letak banyak microprocessor. Dia ada slot banyak. Tak macam dengan laptop ataupun desktop you all kan. Letak satu je kan. Untuk server memang dia akan ada lebih daripada satu boleh letak processor. Sekarang benda dah senang, boleh letak core. Kalau kita server dia ada double slot, bayangkanlah dalam CPU kita dah Xeon dah kata berapa core? 8 core. Xeon 8 core hyperthreading pula kan. So dah jadi 16. Lepas tu ada dua pula microprocessor yang install, chip tu ada 2. Kan, memang double lah. Okay, so original CPU had a single core. That means the physical CPU had a single central processing unit on it. To increase performance, manufacturer add additional core or central processing unit. A dual-core CPU has two central processing units, so it appears to the operating system as two CPUs. A CPU with two core, for example, could run two different process at the same time. Kan? Kalau kita boleh fikir tu, dah dia boleh different process lah. Ni yang kita panggil hyper-threading tadi kan. So this speed up your system because your computer can do multiple things at once. Kan? Yang ni kita buat multi-processing dulu kan. Unix multi-processing. Betul tak?
Betul.
Sekarang kita nak buat hyper-threading, kita nak buat multi-threading kan. Kita nak parallel. Kita nak buat satu job kita saja. Kita nak kira nak count kuasa 2, tapi kita pakai semua core. So kita pakai hyper-threading lah. Right? Satu kerja kita boleh satu program kita boleh guna multiple processor. So kalau kata ada 2 proses, dah tentu kita boleh pakai hyper-threading untuk ataupun multiprocessing untuk setiap proses tu lain-lain core kan. Alright, so a dual core CPU literally has two central processing unit on the CPU chip. So a quad core, kalau quad core ada 4 lah. Octa core 8 kan. Alright. So core versus hyperthread. In hyperthreading, the operating system is tricked into seeing 2 CPU for each actual CPU core. They are not tricked on multi-core. A dual core CPU literally has 2 central processing unit on the CPU chip. So a quad core CPU has 4 central processing unit, and octa-core CPU has 8 central processing unit, and so on. So modern CPU now have both multiple core and hyperthreading technology. So dual core CPU with hyperthreading appears as 4 core to your operating system. Hyperthreading is no substitute for additional core, but a dual core CPU with hyperthreading should perform better than a dual core CPU without hyperthreading. Ada juga dulu dual core tak ada hyperthreading. Tapi kita fikir sekarang semua dual core mesti ada hyperthreading punya. Kan? Yang tak ada Pentium 4 pun tak ada dual core, dah ada hyperthreading kan. Itu tahun 2002 dulu kan. Sekarang kita ada banyak lagi prosesor. Pernah dengar Celeron? Celeron sebenarnya dah lama kan, tapi dia ada ARM Snapdragon kan, yang bukan Intel punya kan.
Ya, ada Zat ada. Yang tu kat phone kan, yang Snapdragon tu.
Ya, betul. So next kita tengok how threads works. A thread is the unit of execution within a process. A process can have anywhere from just one thread to many threads. So dalam proses, thread ni macam anak-anak pada proses lah. Kan kita nak buat satu proses, tapi kita ada banyak job lagi nak buat kan. So ada 1, 2 atau 3 thread kan. So dia boleh buat serentak. So programs are typically stored on disk or in non-volatile memory in a form that can be executed by your computer. The program has been loaded into the computer's memory in binary form, and executing program needs more than just the binary code that tells the computer what to do. The program needs memory and various operating system resources in order to run. So a process is what we call a program that has been loaded into memory along with all the resources it needs to operate. Okay, so untuk thread lighter weight operation, process heavyweight lah kan. Okay, so thread use the memory of process they belong to. Process has its own memory space. Dah proses kan, dia dah ada IPC kan. Kita belajar IPC sebelum ni kan. IPC is slow, tapi inter-thread communication can be faster than IPC. So process context switching between process is more expensive, less expensive untuk threads. Ni. And then threads share memory with other threads of the same process. And process don't share memory with other process. Okay.